Ms. Ewing, and we're going to practice drawing the Bohr model. Practice drawing the Bohr models, and we're going to do a few atoms. So let me see if I can grab us a new slide. Okay. So we want to, let's try drawing, remember your periodic chart is in your textbook in Appendix 4. The first one that we'll try to draw, let's say, is hydrogen. We'll do an easy one. Remember, hydrogen has the electronic symbol H. And if you look in the chart, the atomic mass is equal to 1.008. The atomic number is equal to 1. Remember, we're going to use a rounded atomic mass, so we really should just round that over to 1. The number of protons is equal to 1. Because remember, the atomic number represents the number of protons that are represented in the nucleus of an atom. The number of electrons, since this guy right now is electrically neutral, is equal to 1. Remember, protons balances the electrons, unless we've given one away or taken one or shared them unequally. So right now we've got this match on electrons. And then finally, we need to calculate our number of neutrons. Remember, neutrons is are going to be equal to, the way that we can find the neutrons is to take the mass and subtract the number of protons or the atomic number, and that's going to give us the number of neutrons. So we've got 1. Remember, let's just write that mass up at the top is equal to number of protons plus number of neutrons. So if we know that the mass is 1, number of protons is 1, and we don't know the number of neutrons, we would subtract 1 from both sides, and that's going to give us 1 minus 1 is equal to 1 minus 1 plus n. And that's going to give us n is equal to 0. The number of neutrons is 0. So when we draw hydrogen, we're going to put 1 proton in the nucleus. We don't have any neutrons, so we don't have to worry about that. And then we have 1 electron, and we're going to put that in the 1 shell. You remember, the first shell can hold 2, but we only have 1, so we're going to put 1 in that shell. Alrighty. Let's go on to the next one. Let's try calcium. Some of you did that today in class, so let's do calcium. Alright, we need to find the atomic mass. We need to find the mass is equal to 40. The atomic number is equal to 20. So therefore we know the number of protons and we know the number of electrons. So the protons is equal to 20. The number of electrons is equal to 20. The number of neutrons, we get that by subtracting 40 minus 20. So mass minus the atomic number, or mass minus protons, it's going to give us the number of neutrons, so that's going to give us 20 as well. So, question for you. What goes in the nucleus? Protons and neutrons. So we got 20 protons. We have 20 neutrons. We're going to put those in the nucleus. And then how many shells do we need? I don't hear you. Possibly 3 or 4. So how many? 1, 2 go in the first shell. The second shell has 8. 1, 2, 3, 4, 5, 6, 7, 8. The next shell, so that gives us a total 10 so far. The next shell has how many? 8. 1, 2, 3, 4, 5, 6, 7, 8. So now we're up to 18. That leaves 2 in the outer shell. So that's 1 and 2. So now we have calcium, and we know that it's unstable because it doesn't have a complete valence shell. Remember, the valence shell is the outermost shell. And we know that it is going to be seeking to interact with other atoms because of its inadequate filling of the outer shell. So let's do one more and we'll call it quits. Okay. And grab us another shell. Alright, let's do one that you did in class several times. Let's do, no, I take that back. Yeah. Let's do sodium. Sodium is Na. Alright, sodium has a mass of 22.99, so we'll just write 23. Atomic number is equal to 11. The number of protons is equal to how much? 11. Electrons equal to 11. The number of neutrons is found by doing what? That is correct. Taking our mass, subtracting the number of protons, and that gives us a number of 12. Alright, so we know protons and neutrons go in the nucleus, so we've got 11 protons, 12 of the neutrons. We end up with 3 shells, looks like, so that's 2 in the first shell, 8 in the second shell, and the final shell will have 1 left over. Alrighty, I hope that helps you learn how to construct your BOHR models. And remember, always put your symbol out to the side or at the top, and then put your protons and your neutrons in the nucleus, and then your electrons orbiting about the nucleus in the electron shells. See you in class.